These are the basic pieces. We have 3 tiny little servos, all wired up to a Raspberry Pi Pico. So this is a really small microcontroller, and just 3 different pins onto the 3 control lines of the servos, and then the positive and negative voltage lines are all connected together. Those will be connected to like a 5-volt or 6-volt supply, and then we'll run the Pi separately over USB, and that's where we'll send the commands. The only other parts of this are a base that everything's going to go into, a little bracket to hold one servo on top of another, and this tube into which we're going to place the light-dependent resistor. So this is going to go into one side, and then that's going to scan across. And to read this, these are just a resistor that changes value depending on how much light is hitting it. So if I measure the resistance at the moment, we see that it's maybe less than 1 kilo ohm. If I point it away from the light, it's suddenly 5 kilo ohms, maybe 10 kilo ohms, 20 kilo ohms once it's in shadow. So this is variable depending on how much light is hitting it. And so we're going to hook this up in series with a fixed resistor, 10 kilo ohm, and we're going to measure the voltage in the middle. So we're going to see the voltage drop across this varying resistor when the total voltage is fixed, say 3.3 or 5 volts. And so then the way this is going to assemble, one of these is going to have the tube with the resistor in it, the light-dependent resistor. The other is going to have the bracket so that the first one can sit in. And so now this is going to be able to rotate across and up and down, and that's going to give us our 2-dimensional-ish motion, and that's all going to slot into the base like so. Nice press fit rather than having to do any screws, although you can add a little screw hole and such if you need. And then the Raspberry Pi has these mounting holes that we can screw into the brackets here. Oh, got my measurements off apparently, but shouldn't be too big of a problem. So it's important to check that the range of motion matches what you'd like. These have end stops, so if I put this on the wrong angle, it wouldn't be able to turn the way I want. But once you're satisfied with that, you can take the tiny little screws that come with the servos and use those to temporarily attach the servo horns, they're called. And then likewise for the second servo, just check that it has the range of motion that you want, that it's roughly in the center horizontally in this design. And then in that case, I can come in through this hole here, place the little servo screw, and then probably cap this with some gaffer tape. And the reason I'm doing that is so light doesn't leak in and spoil the directionality of our measurement. So I want to be able to read the voltage between the light-dependent resistor and the fixed resistor. So to do that, I'm going to have one pin connected to the analog to digital converter voltage reference, one connected to this pin that has analog capabilities, and one connected to ground. So if I orient the pin out to the device, you'll see it's some of these connections here. But before I even do that, I'm going to fix in the light-dependent resistor into the tube, and I'm just going to use some hot glue to do that. Okay, then while I wait for that to cool, we can start on the wiring. So for this sensor, I'm going to use this nice silicon wire. It's very flexible, not high current capacity, but we don't need that. We're just sensing an analog voltage signal. So I'm going to use some of this to wire up the light-dependent resistor to the pins. And what we'll do is we'll have the 10K resistor from the reference voltage to the analog pin, and then the light-dependent resistor from the analog pin to ground. Alright, that went mostly according to plan. I had to re-glue this bracket back on. But if you look here, you'll see we have the resistor between VREF and the pin we'll be reading. And then we have the light dependent resistor between that pin and the one next to it. I'm going to trim off the ends and make sure that there's no continuity between those 3 pins, that the measured resistance is 10k and then some variable amount of resistance as opposed to a dead short. Alright, and I'll have the servos powered by this 1000 watt power supply, which is slightly overkill, and some Kocho, which I'll explain shortly, but when I run it, is going to sweep the servos through some motion and back, and all the while it's reading the value on the light dependent resistor.